Hello folks, this is the third lecture in the Matlab series. In the last lecture, I have already told you the Gauss-Jacobi method and Gauss-Seidel method. In this lecture, I will be covered the to solve the system linear equation with the method by using the method of Gauss Elimination method and LU decomposition method. So before going to the MATLAB session, first I will be covered the theory part, and after covering the theory, I will be explaining the algorithm for each method, and then after explaining the algorithm, then we are proceed to the MATLAB session. So now start with the first method today, that is the Gauss elimination method, and uh, Gauss elimination method. So to explain the Gauss elimination method. So in Gauss elimination, the method is like that we have to convert the coefficient matrix into the upper or lower triangular matrix. So we have a system of linear equation. Then we have to make the augmented matrix, and that augmented matrix will be converted into the upper or lower triangular matrix. According to that, we have to reverse substitute or back substitute to then find the final answer. So to explain this thought, I will actually using some simple example. And the example I will taking is that 6x plus y plus z is equal to 105. 4x plus 8y plus 3z is equal to 155, and 5x plus 4y minus 10z is equal to 65. So for this method, the coefficient matrices look like A is coefficient matrix A is 6, 1, 1, 4, 8, 3, 5, 4, minus 10, and the constant matrix look like to be 105, 155, and 65. So actually we are solving a equation Ax is equal to B, in which A is written there and B is written there, which is a constant matrix. Okay. And we have to find the x vector, that is the x, y, and z value, and which is find by making it to the upper triangular. So to system to have a unique solution, it is necessary to find the rank of the matrix. And for here for this system, the rank of RA should be equal to the rank of RB and should be equal to the order of the uh, order of the matrix. And RAB is the augmented matrix, in which the B matrix is the fourth column of the A matrix. So here the rank should come out to be 3, and the order is same as the number of variable and should out to be 3. So it have the unique solution. Since the rank and order and rank of AB and order of is same, it have a unique solution. Now we will solve this equation and first make the augmented matrix. So the augmented matrix of AB is look like to be 6, 1, 1, 4, 8, 3, 5, 4, minus 10, and the fourth column should be the B column, and that should be 105, 155, and 65. Okay, now in the now in the Gauss elimination method, we have to ensure that we have to do only the row operation, not column operation. So we will apply the row operation, and row operation should likely be R2 goes R2 minus R2 by 6 into R1. After doing this row operation, now let's check it the how the second row look like. The first row will be the same because I am doing the operation the second row. Since R2 goes to R2 plus R2 by 6, so first element will be 0, and the second element of the row 2 is 8 minus 8 divided by 6 multiplied by 1, which is come out to be the 40 by 6. Come out to the 40 by 6, and similarly the third is 3 minus 3 by 6 multiplied by 1, and it come out to be the 15 by 6, and similarly the B column 155. I will be make a question mark there, and we will solve this thing in the MATLAB. So I will not go in depth of the solving part. So I will put a question mark there, and similarly the third row will come out to be the 0, 0, and some factory values here. So after doing these row operations, this augmented matrix will change look like this, and this augmented matrix is called the upper triangular matrix, and upper triangular matrix. And actually, if we saw the original question, we have an original question like we have to solve the Ax is equal to B, in which A come to be the upper triangular matrix and B actually converted the B new. So we actually need to find the x, y, and z here. So to find the x, y, and z, we have to reverse substitute the values to find the x, y, and z. Why I have called the reverse substitute? Because it is easily to find the z value from the upper triangular matrix, and then we will find the x and y value. Uh, to explain the above point is like that in the in the AB upper triangular matrix, if we see the third row has A11, A31 and 32 as zeros, and A33 have some values. So A33 will be multiplied by Z, and it gives the B3 value. So Z can easily be find here B3 divided by A33. So we can easily find the Z value. Then we use the Z value to find the Y value, and then we use the Y and Z value to find the X value. So that is why I have called this the reverse substitution. Now we start to write the algorithm to make the MATLAB code. So the algorithm is like that. First start, then we have to define the equation, uh, all three equation we have to define, all three, no, not all, define all the equation, that is define all matrix and the constant matrix. Then after defining the augmented matrix and constant matrix, we have to define the augmented matrix, because we have to do the row operation, and row operation will be done on the augmented matrix, that's how A and B both matrix will be changed. A become a UTM, upper triangular matrix, and B become the B new. So after augmented matrix, we have to convert this augmented matrix the upper triangular matrix, that is the UTM. Then we have to reverse substitute the values to get the X, Y, and Z. So after reverse substitute, we have to print these values, because these are the final answers. Print these values, and after print, the method is the algorithm will stop. So this is the whole algorithm for the Gauss elimination method, and the similarly algorithm will be done for the LU decomposition. But I will be explaining in a bit of while after explaining the code. I will explain the algorithm for the LU decomposition method. So let's dive into the MATLAB code and see how to write the code. After coming to the MATLAB window, first we have to go into the editor file, that is the script file. The command to go to edit file is edit. Then we will save this file, that is the Gauss elimination method with naming. And after saving the file, Gauss elimination, and the first thing we will do is first clear the workspace, clear the screen, and close all the windows that is open in the MATLAB other than the command window. So this is the my habit to write the any script file. Then we commented out this. This is the code for the Gauss elimination method. And next we will write the code. As the algorithm I have defined, first we have to write the coefficient and the coefficient and constant matrix. So for particular equation, the coefficient matrix look like to be 611, 483, and 54 minus 10. And to define the column, we have to space separate it with the space, and to define the row, we have to separate with the column semicolon. So the coefficient matrix is B, and B defined with the 105, 155, and 65, and they are separated by the semicolon. And next we have to define the augmented matrix. And augmented matrix is the matrix it have both A and B matrices. Since if for particular question I have defined the A matrix, but if it is a user defined, then we don't know how many equation we have. So to be generalized uh, in that manner, we have to use the length of matrix which is equal to 3 for here. But to be generalized, we will use the command length and we will store this length in the k vector. Yeah. After defining the length of the matrix, now we have to convert this augmented matrix into upper triangular matrix. So now the code is for the upper triangular matrix, and for the upper triangular matrix I have to use the nested for loop, in which I've used the j vector. J is going from the 1 to k minus 1, that is the total number of variable minus 1, and the other variable is I, and I start from the j plus 1 and it goes for the length of a, that is the k. Here j is a dummy variable because I need to call a particular row and particular column. So G is for dummy variable, and whereas I is for the to call the particular row, for the call the particular row. Okay, uh, it is clear up to now, I suppose. So now I have to perform the upper triangular matrix, or that is the row operation in the AB matrix. So for AB matrix, I have to call the second row, that is the AB of I comma I, or all column. So I is for the row actually. So AB I for all column, and actually I'm going to use that row and subtract it with the all column. So AB that row I row and all column, and the way I have done in the theory part, that is R2 goes to R2 minus R2 by 6 into R1, as shown here. uh, uh, the same iteration I have to use in the MATLAB, and how to write in the MATLAB, in shortly I will be explaining it. So since if it's considered R2, I solve for R2. So first two lines similar, R2 goes to R2 minus R2 divided by 6. That is 6 is the first row, first column. Okay, so AB, first second row all column divide by AB j comma j, because for third row we have to divide by second row, second column, that's the ABJJ, and it will multiply by AB of jth row all column. So uh, that's how that line will be coded in generalized way in the MATLAB, and it will be run for the third row. Close all the loop. After closing a loop, we have the converted matrices. Now we have to now from that converter matrix we have to take the upper triangular matrix, and to do that we have to take all three rows and first three columns and for that we have this code. And for the last matrix, that is the B new matrix, it should be the last column of that augmented matrix. It should be the all rows in the last column. There is a key plus one, and then we will display the upper triangular matrix and the display the B new matrix before going to the reverse substitute. Before going to reverse substitute the equation, first I want to explain you how to find the determinant from the upper triangular matrix, because to find a determinant from the upper triangular matrix very simple. I will explain it here. Let us consider if we have the upper triangular matrix that is look like to be U11, U12, U13, 0, U22, U23, 0, 0, and U33. This is the upper triangular matrix. So for if we find the determinant, so determinant come out to be the U11 multiplied by U22 and multiplied by U33. It is very simple. You find the determinant of upper triangle and it will come out to be this the diagonal element multiplication, and which is similar to the determinant of the A matrix, that is the coefficient matrix. We will verify it after running the code. Now, how to write this in the Matlab code? It is very simple. I will show you. So from now on, I will write the code for the determinant. So I will comment out the code for the finding the determinant of the matrix. So to find the determinant, we first use the dummy variable, that is determinant, and I will give the name of I will give the value to be the one, determinant is equal to one, and I will use a for loop here, and the loop will go from 1 to length of the A, and I will be multiplied the diagonal element, so determinant is equal to determinant multiplied by UTM of S comma S, and end this, and we will display the value of the determinant. This is how simple to find the determinant. After defining the determinant, we will reverse substitute the reverse substitute to find the x, y, and z values. So from now, the code for the reverse substitution, which is I commented it out. Uh, so here actually we have three variable. So x can be defined as x zeros, k comma 1. So zeros is like a 0, 0, 0 of one column with element of length of A. So we can easily find the Z value for or we can say the last variable, that is the at the kth row. So it can be easily found. So xk is equal to b of new k divided by u of kk. It can be easily find, so we can write this. So up till now we have to find till now we have find the z value. So from now on we have to find the y and x value with the using of z value to use to know to find the value of y, and then we use the value of y and z to find the value of x. So we have to actually go back. So for that we have to make a loop which goes from the second row to first row, that is k minus 1 to 1, and then and we have to sum all the elements before finding the y. Actually we have to find the x. If you have to find the x, we have to sum the y and z coefficient and then subtract it from the b3 and divide by the coefficient of x. So that's here the sum is using, and we will explain it later in the broader sense. First write the code, and so we have given the sum, and then the loop is for L is go from the first row to third row, or we can say first column to third column. So uh, then after that sum is equal to sum u of that row and column multiply the column xl, and then we have the sum of these values. After summing of these values we have to find the xp, that is the x values. So xp is equal to p is actually uh, k minus 1, that is 2. So x2 is equal to b nu of p divided by uh, minus sum, actually minus sum, and divided by u of pp. So this is the code completed. Uh, so now we will print these values. So we use the fprintf, and fprintf is simply print these command in the command window, and I will write is the solution for the linear equation is, and then we display the value of capital X, in which it have the x, y, and z, all three values. So it can be written like that. The fprintf, the solution for the above linear equation is, then display capital X. So now I will further explain the for command in the detailed way. So I will explain it in the one note. Uh, so here is goes. So if the upper triangular matrix is look like to be U1 is equal to U11, U12, U13, 0, U22, U23, 0, 0, U33, and our XYZ is X, Y, and Z, and other is B1, B2, and B3, that is a B new vector. So we can easily find the Z. So Z it should be U33 into Z is equal to B33, so Z is equal to B3 by U33. So to find the Y, we actually need to go to the second row. So if we multiply the second row, so U22 into Y plus U23 into Z is equal to V2. So U23 into Z is actually the value that is stored in the sum that is written in the Matlab command. And actually we have find the Z value in the above, so we can use the value of Z from there in the Matlab command. So to find the Y is equal to P2 minus sum divided by U22, which is exactly written in the Matlab command. So if we find the X value, so X is equal to B1 minus U12Y plus U13Z. I am not writing that, but it is U13Z divided by U11. So actually U12Y plus U13Z is stored in the sum command, some variable in the MATLAB command. So actually I directly subtracted the sum from V1 and divided by U11 to get the X. That is the way, that is that for loop doing there in 3 lines. Now run the code and let's see what happens. So there is an error here, is saying inner matrix dimension must agree. Okay. The error is in the line 12, and I have write the ABI comma all column. Actually, I have to write the ABI comma jth column, not all column. Actually, I'm not multiplying the matrix multiplication. Now run it again, and we have another error. And error is index exceed matrix dimension in line 23. Line 23. Oh, it is. Okay, there is a problem. Actually, I have to write, we need 3 rows and 3 columns, not 2 columns. So there is no key management, actually is K. And run it again, and we have the final answer. This is our rectangular matrix, and this is our the B new matrix. minus 521 is of the determinant, and the answer is 15, 10, and 5. X is coming to be the upper, so there is a backslash in the f printf, and then we have very nice way to look the result, that is 15, 10, and 5. Now come to the second lecture of today's second method of today's lecture, that is the LU decomposition method. LU decomposition method. LU, sorry, LU decomposition. So in LU decomposition, actually we have the equation similarly to before. Ax is equal to b, Ax is equal to b, where L is become LU, where L is for lower triangular matrix LTM and U is upper triangular matrix as UTM, which we find in the Gauss Elimination method. In LU decomposition, actually there are two methods. First is the Doolittle method, and the second is Koleski method. So the Doolittle method will be I will be going to explain from the Matlab code, and there is a difference in the Koleski and Doolittle method, and the Doolittle method I am going to explain. And the Doolittle method is that we have the upper triangular matrix which will be find as user in the from the Gauss elimination method as we find, and the L matrix is like we have the diagonal element of 1 1 1 1 1 1, and then the there is L21 variable, L31, and L32. Uh, Despite of that, all the other variable like 1 2 1 3 and 2 3 are zeros in the code in the Doolittle model. Where in the Koleski method, we don't have the L and U different, but in Koleski we have A is equal to L into L transpose. We have L matrix in which the diagonal elements are not one. Actually, the diagonal element will be have L11, L22, L33, and then L21, L31, L32. So we have L transpose, and L transpose nothing but the upper triangular matrix. So we don't have too much calculate variables in the Koleski method. So we will start with the Doolittle method, and Doolittle method, as I described earlier, the lower triangular matrix is like this only as in the screen, and then we have the upper triangular matrix which we find in the Gauss elimination method, which is written in the screen. uh, so uh, now uh, actually if you see Ax is equal to b, we have Lux is equal to b. So instead of finding Lux is equal to b, we have to find Lux is equal to y. So first we have to find Ly is equal to b, where we know the b value and L value L, but we don't know the y. So first we find the y, it is y1, y2, y3, and then after finding the y1, y2, y3, we find the x, and the equation for that x is ux is equal to y, and to find the y here, since L is the lower triangular matrix, we have to forward substitute. Since y1 can be easily find as before, z is easily find, here y1 can easily find, then we go to y2 and y3. So this is called the forward substitute to find y1, y2, y2 and y3, and then we find the ux is equal to y for reverse substitution. Well, since US is equal to y, this is for the reverse substitution, and we actually saw the code for the Gauss elimination method. Now look the algorithm of this LU decomposition method. First is start, then the same way we done in the Gauss elimination, we have to need the coefficient matrix A and the coefficient matrix B. Define A and B. Then we have to need the augment. Actually, we don't need the augmented matrix here. Convert the A matrix into the lower and upper triangular matrix, the L and U. And then after having the lower triangular matrix, we need to forward substitute to find the value of y1, y2, y3. Forward substitute. And then after forward substitution, we need to solve the equation of Ly is equal to B. Sorry, Ux is equal to Y. Then we need a reverse substitution because we need U for U it is upper triangular matrix. Then we have the final answer. We have to print those values and then stop. So this is the algorithm for the LU decomposition, and there is one more step from the Gauss elimination is that we have to forward substitution before reverse substitution. This is the extra step in the LU decomposition method. Now dive into the Matlab. So in the Matlab window, first we have to go to the script file. So for script file, we will write a code of edit command here. First edit, new script file will be shown. And after edit, we will be used close, clear, and CLC as usual. As before in the Gauss elimination, we will write the code for the this is LU decomposition, and we have the coefficient matrix as similar to the Gauss elimination. This is the A vector, and which is come out to be 611, 483, and 54 minus 10. And then we need the coefficient matrix, that is the B matrix, and B come out to be the 105, 155, and 65, and I will define it differently here and use the transpose here. Then we need the length of the A because we need how many equations are there to be generalized similar to the Gauss elimination. Now, after getting the length of the A, in LU decomposition, we need the lower triangular matrix and the upper triangular matrix, both matrix. So we have to write first we have to define the L matrix. That is L is for the lower triangular matrix, and this L matrix should be the uh, should have the diagonal element to be 111 and all other will be zeros, and then I will define the L21, L31 and L32 element. So to give the diagonal element of 111, the command is I, and I will be show you in the command window that's how I command should look like, and this is the I command that it look like that it will give me the diagonal element to be the 111 and all other element to be 0. So now I actually have to return the L21, L31 and L32. So from now on, this is the code for the lower triangular matrix and upper triangular matrix. Similar to the Gauss elimination method, the I have to use a nested for loop, and in which the j will go from the 1 to k minus 1, and I go from j to k. Uh, so before write the upper triangular matrix, we have to write the lower triangular matrix, because if we write the upper triangular matrix before, then it will be changed, because the U21 is 0 for upper triangular matrix, and if we use U21 there, if A is changed to U21 in upper triangular matrix, then we cannot use the lower triangular matrix. We cannot make the lower triangular matrix. So first make the lower triangular matrix, and the idea to make the lower triangular matrix is that we need to enter the values of L21, L31, L32. So we need 2 and 3 rows and 1 and 2 column. So to do this is I is for the rows and J is for the column here. So Lij and Lij. So Lij is equal to actually A of Ij uh, of divided by A of J comma J. It simply is very simple. It is uh, uh, coefficient matrix that row column and divided by the diagonal element of that column of the first column. So that's how we get the lower triangular matrix, and the for upper triangular matrix is similar to the Gauss elimination method, and it should be the that row all column is equal to that row all column minus of that Aij R2 divided by R6 so Aij divided by Ajj multiplied by Aj of all row all column, then and now I will explain it again how this lower triangular matrix will came and why lower triangular matrix uh, be before than upper triangular matrix in the one notes. One note. The reason behind is that let us consider this. If we have a like this 611,483,54 - 10, and if I convert this A to the upper triangular matrix before, then this element should be 0 for upper triangular matrix. So if this is 0 uh, before applying the lower triangular matrix, I apply the upper triangular matrix, this is 0, then I don't have the lower triangular matrix here. So that's why we need first to define the lower triangular matrix, and the way to do the lower triangular matrix is this. The this element should be 4 by 6, and the element of 3 1 should be 5 by 6, element of 3 2 will be the 4 by 8. It should be the 4 by 8. That's how we will define the lower triangular matrix. Yeah, and this is I have defined in the Matlab code the same way. Now we have the lower triangular matrix, upper triangular matrix. Now we display the lower triangular matrix, it is L, and then we will give the upper triangular matrix to U variable, that is U, and display the U matrix. And now uh, we have actually solving the equation of Lux is equal to B, where Ux is equal to Y. So first we have to solve the Ly is equal to B. So in Ly is equal to B, we know the B, that is a constant matrix, and we know the L matrix, which is calculated out here. So we actually need the Y. So for that, it is the forward substitution. Because for L matrix, we can easily know the value of Y1, and then we found the Y2, then we find the Y3. So it is called a forward substitution. So here we have to do the forward substitution. So for forward substitution, we just define the y should be the zeros k comma 1, and the y1 easily is find y1 is equal to b1 divided by l11, 1 divided by l11. Now we have to do the forward substitution, so we need you to use the nested for loop here. So how to proceed from here? So I will explain it in the OneDrive how to proceed from here. Actually, we Actually, we have the L matrix, and it is like L is equal to 1 0 0. Now L1 2 1, L2 2, and 2 2 is 1, and L3 1, L3 2, and 1. So here 1 is here first way is easily defined, that is the y1. So from y1 we have to define the y2 and then y3. Okay, so we need to use the row 2 and row 3 here, not row 1. So we have to go forward from here. Okay, so for going forward, we will use the dummy variable c here, and c will go from row 2 to row 3. Okay, now we will give a dummy variable sum which is equal to 0, and nested for, and that for loop will go from the c minus 1 to 1. Actually, we go from second and third row, but we need first and second column, because we have, for second row we calculate the second column, but we need the first column. For third row we calculate the third column, actually the y3, but we need first and second column. So that's why the second loop is for DC minus 1 to 1. And now, now actually I forgot to write sum is equal to 0 here. So write sum is equal to 0 here. And then this sum is equal to sum plus, and then we use lower triangular matrix L, and this L should be L and C comma D multiplied by Y D, colon, and then end, and then we use the Y of C is equal to B of C minus sum divided by L of CC. Then it is complete the forward substitution completed. Now we will write the code for the reverse substitution, and this code is same for similar to the Gauss elimination method. So I will not explain in detail this again. I will just iterate what I will writing in the command window. So here the variable should be the x. So x will be the zeros k comma 1, because how many variable should be the length of a. So x k x zeros k comma 1, and the z x3 can easily be found. So xk is equal to yk divided by ukk, and then the for loop, and for loop go from the second and 1, so it will go from the k minus 1 to 1, and thus then we will define a sum is equal to 0, and then the second for loop is go from the p plus 1 to k, because we need the column 2 and 3 column, uh, actually. So p plus 1 to k, and then sum is equal to sum u of p comma l into x of l, and then this loop will be closed. We have the sum value. After the sum value, we have to just substitute it, then subtract it from the y value. So xp is equal to y of p minus uh, sum divided by u of pp. Hold on. Uh, I have I have done a, genuine mistake here, but I want to see how I will find that mistakes, because MATLAB will not tell you. It will give you a solution, and so display that x and then run the command. Let's see uh, uh, how to find that mistake there. So first save the file and do decomposition, and then run with F5. So after running this, it will give me a value of x y z 13.5, 19.455. Actually, we know the value of it is 10, 15, and 5, 15, 10, and 5. So I know there is a mistake there. So now how I find that mistake, it's important. So I have displayed the lower triangular matrix and upper triangular matrix. Since the upper triangular matrix is similar to what I need, what is in the Gauss elimination method, and lower triangular matrix is same, and the y vector is also be the same as b new vector. So the mistake should be after finding the y vector, or they and the value of z is also the correct. So the mistake will be the after the y. So the mistake in the reverse substitution method. So here I found the mistake. It should not be b. It should be capital Y. And after doing that, capital Y, I will rerun the command with F5, and we saw, and we see that we got the correct answer, that is 15, 10, and 5, which is similar to the Gauss elimination method. Okay, so this is the lower triangular matrix, upper triangular matrix. This is the y vector, that is the, and this is the x. So that is how we can write the code for the LU decomposition and Gauss elimination method. I think it is clear. It is all the step I have explained properly here. So I don't think you have any doubt here. And if you want to generalize this code, just you have to change. You have to just change A should be the user defined. A and B should be the user defined. Instead of giving the values, it should be a user defined. Then the code will be the generalized code. So that's all from my side, and uh, uh, the next lecture should be on the uh, interpolation, that is the Newton divided difference and the Lagrangian interpolation. So that's all from my side. Okay, bye.